Okay, so this video is going to talk about how to use factored form. There we go. Great, I just crossed that out, but I meant to underline it. I should get a little more sleep maybe. How to use factored form of a polynomial to quickly sketch it, because time is important and we want to do things quickly, especially in this world we live in. Okay, so this video assumes you've already watched previous videos on let's see, what was it? Basic shapes of polynomial functions and the degree of a function and those kinds of things, okay? So this video, here's just a quick recap of what I've talked about in a previous video, okay? So you're welcome to just push pause. I'll get the pen out of the way so when you push pause you won't mess up. Remember that all of these functions shown here are positive. If they were negative, then they would be flipped upside down, okay? All right, now you can always push pause and look at this. I'm going to move on. Here is a situation. We're supposed to sketch this thing. So we might just, a sketch, by the way, doesn't have to be perfect. It's just something we sketch quickly. Okay? So we don't have to be artists here. Although you can say you are a sketch artist in math, and many people can do it. Whereas if I asked you to draw a face right here, it probably wouldn't look so great because most of us can't draw faces very well, especially the eyes and the nose, very difficult. However, one of these graphs, not so bad. Enough with the jokes. Here we go. Here we have a factored form of a polynomial. I mean, this thing used to look like, it used to look like something like that. Let's see, plus 3x minus 2x, so plus x minus 6. It used to look like this. Then someone went ahead and factored it like this, and this is how they gave it to us. And it's quite, oh great, there we go, that isn't hard to get back. And the reason why factoring is so cool, and again, this goes back to a video that was done called How to Solve a Polynomial Function or something like that. And it shows that when we factor a polynomial, what we're able to do is we're able to see the x-intercepts or the roots or the zeros. I'm not sure how you like to call them or how your teacher calls them. So that's the places where this shape, this thing here, I guess it's going to be a parabola, where it cuts through this x-axis right here. Okay, so in this case, what you do is you take the number that is opposite to the number you see. So negative 2, how would you make this whole thing in brackets become 0? Well, 2 minus 2 is 0. So x is going to be, I might as well write it down, the x-intercepts will be 2, and this one here will be, can you tell me? Thank you, negative 3. 1, 2, 3, there's one spot, and 2 is the other spot. Okay, because we know basic things about graphs, like we see right here, this particular one is a quadratic. It's a degree of 2, because if we multiplied this out, before you saw when I multiplied it out that we had an x squared, the degree would be 2. Again, that's another video. Just before this one, something about how to find the degree of a polynomial, and that's another video. I just can't put them all in one, otherwise you're going to be watching a 1 hour long video and no one will watch it. It would just be too long. You would give up on me, be honest. Okay, so another way to tell the degree of a polynomial, if it's factored, is you can just see how many brackets there are like this, and just in your mind say, well, x times x is going to be x squared. This is going to be a degree of 2, so it's going to look like a parabola. Is it positive? Yeah, there's no negative sign. And if there was a negative sign right here, then that would cause it to be flipped upside down. But no, this is positive. It's going to be a parabola. So you can be confident that it's going to cut through here, come down somewhere through the y-axis. We don't really have to worry about where it's cutting through here. But these two spots are important, the negative 3 and the 2. And there is our basic sketch of this polynomial function. Okay? Let's look at another question. It's always good to do more than one. Well, if you look at this one, can you make a guess? Well, in the brackets here we have x. We have another x in brackets over here. If we were to multiply this all out, not that we're going to do that, but if we did, we would end up having an x squared somewhere, and there would be no x cubed or anything like that. It would just be x squared. So let's draw our Cartesian plane. We're just sketching, so we're not looking for perfection here. Let's look for the roots or the zeros or the x-intercepts. So the x-intercepts would be at 2 and -3. Hey, that kind of reminds me of the last question. There's 2, there's -3. And just because there was a number in the front, that doesn't mean that it has any effect on these x-intercepts here. However, there is this thing right there called a negative sign. That means that this is going to be a parabola, but it's not going to be facing upwards. It's not going to be positive and happy. It's going to be negative and sad because of the negative sign. There we go. We have ourselves a parabola sketched to perfection. Okay? Here's another question. Now, does this look like a parabola? We've got an x there, an x there, and an x there. So, one thing we can say is x times x times x is not x squared. It's going to have an x cubed. Now, let's go back to the basic parabolas. Remember, an x cubed is a cubic function of degree 3. That's the fancy math language there. So generally, it will start in this corner, in this third quadrant here. It'll go up, come through here, and end up in the first quadrant, going upwards forever. Okay? Well, let's go back to the question we're on. Is it positive? Yes, it is. So all we have to do is quickly, let's do the x-intercepts really fast, so as not to bore you. We would have 2 and 3. Not -3. I almost said -3. That's right. You heard correctly. And over here, we're going to have a -5. That's right. I wanted to say -5 that time. Here we go. 2, 3, and -5. 1, 2, 3, 4, 5. What a beautiful sketch. I might as well write that in there. 2 and 3. Ooh, this parabola, remember, it's going to start at the lower left, come like this, go down like that, and come up this way. Okay, that's the basic shape. By the way, if you want to verify any of these things that we're doing, if you want to look at a really nice graph of these parabolas, then make sure you go to Desmos, and that's the online graphing calculator. It's free. It's also a great app on your phone or on your device. Desmos is really, really useful for graphing things, and it's a beautiful graph that they do. It's not just some basic graph. It's nice looking. You will like it. You'll want to do math all day. Okay, is there any other questions? Yes, there are. Of course there are. Yeah, let's keep going. I don't think I had anything more to say about that. Here's our Cartesian plane. What about this graph? Well, 1, 2, 3. I see 3 x's. It's going to be x cubed at some point. However, I see the negative sign in front, so it's going to be flipped upside down from this graph. So instead of starting down here, it's going to start up here and kind of do a mirror image upside down. Let's write in our x-intercepts here. Ooh, how do you like the blue? It's a nice change of pace. We've got -2 and -3. What else? And 5. 1, 2, 3, 4, 5. Boy, these numbers look similar. I must have not been very imaginative. 1, 2, 3. That's -3, and -2 is right there. Put a little dot on each x-intercept. Okay. So, let's use red. Remember, we're starting up here. Okay, we're starting up here. Then it's going to have to move up here somehow, and then go like this. For all I know, that's a terrible looking graph, but when a teacher says to sketch, that does not mean it has to look beautiful, okay? If you want it to look beautiful, use Desmos and it's a graphing calculator, or heck, do this using a table of values and a piece of graph paper. It's way slower to do that, though. This is so much faster and fun. That was our last question, folks. I guess I don't need to review all of the things we have done together just now because you can always push rewind on your YouTube video. Have a great day.